In this lesson, we're looking at what are bearings and what they're used for. So bearings are used in navigation for geographical purposes. There are two types of bearings out there, which include three-figure bearings, which means three numbers that would tell what a bearing is. And there's another name for that, which is called true bearings, and we use that more often. The second one, what they call that, is compass bearings. Okay. Now, both of these are used, both of these are discussed and are needed for what you need to know in year 10 and beyond. So let's have a look at the first one, which is three-figure bearings, or in this case, true bearings, which I've written as a title here. They use angles from 0 degrees all the way to 360 degrees. Now, you notice 360 degrees, what angle does that actually represent? That's a revolution, okay? So revolution is like that, okay? So you start at the point and you end at the same point, going in either clockwise or anti-clockwise direction. But for true bearings, the amount of turn that you actually analyze and give as a true bearing as a number is measured clockwise from north, and we use three numbers to represent that, okay, which is 0, 0, 0 degrees, and we're going to look at that right now. So before we actually look at true bearings, you should know your Regulus compass bearings, which represent north pointing upwards, east pointing to the right, south pointing down, and west, which points left. Now, right in between those, okay, right between north and east, okay, is northeast. Right between south and east, okay, using the vertical direction first, is southeast. And between south and west, again, starting with the vertical direction first, so S is southwest. And then north and west here, between that is northwest, okay? So I'm going to write those in detail later on, but let's discuss how would you actually analyze the true bearing of each of these points in the compass. So the first one up here we know is 0, 0, 0 degrees. Okay, so that's directly pointing up north. Now the one that is east is going to be 90 degrees. Okay, but how do we actually write that? We have to write three numbers, starting with the first number as 0, then the 90 degrees like that. And that's because from north, you have to turn a total of 90 degrees to reach this point. Now, what if I start from north and I want to reach this point down here, which is south? How much do I have to turn? I have to turn a total of 180 degrees. Okay, so below right here, I'm going to write 180 degrees. Now, how much do I have to turn to go west from north? So if I start with north, I have to turn this much. That's 3 quadrants worth, or 3 90-degree angles worth, okay, which is 270 degrees. All right. Now let's analyze what these ones are. Okay, so northeast, southeast, southwest, and northwest. Northeast is directly between north and east, and if this angle here is 90 degrees, this splits this apart into 45 and 45 evenly. So northeast is actually 45 degrees. Okay, and how we write that is starting with 0, followed by 45. Okay, so that angle there is 45 degrees. Now, the thing is, each of these angles which I am drawing right here are 45. So if this is already 90, okay, I need to add another 45 here to get to southeast. So 90 plus 45 will get you this angle here, okay? That true bearing will be 135 degrees. Then if I wanted to find out what southwest is, I'll plus another 45 degrees to 180. Okay, so this is 180. I need to add another 45, and that will give us 225 degrees. Whereas northwest, how I can do that is by finding this angle, which is 270 degrees, added with another 45. Okay, so 270 plus by 45 gives you 315 degrees. Okay, and those are just the basics of true bearings. You can have angles in between any of them. You could have this angle even. Okay, that might be like 20 degrees or something like that. All right, and we're now going to use all this knowledge to do a particular question to find the three-figure bearing. So let's have a look at that now. So example 14, write the three-figure bearing of each point from O. So O is the starting point. From O, remember, we have to start with the northerly direction of this compass bearing. And we've got to find out what this angle is from north towards that line that points towards X. Okay? So we know that this is already 90 degrees. Okay? So 90 plus another 20 degrees, represented by that, gives you 110 degrees. That is our true bearing, okay, for where X is, okay, in relation to O. So if you're at O and you're looking this way, okay, how much would you have to turn to look this way in a clockwise direction? That's what we're asking for question B. So to find that out is really simple. This whole angle here that I'm drawing, that is 360 degrees. We just don't want this part, okay? The one I'm shading, we don't want that part, okay? Which is 43 degrees. So if we get 360 degrees, which is that whole entire red angle that I drew before, and I'm going to draw that again, but we minus this part here, okay? Which is 43 degrees, we will get this purple line there. So if we get 360 degrees minus 43 degrees, we will get 317 degrees. So that's the angle represented by the purple line. Okay. Then for question C, from north, we have to turn this much to get to this line. So how do I find that? We know that this angle here is 9 degrees, and this angle that we want to find out, okay, I'm going to write that in purple. Okay, want to find this angle is simply the subtraction of 35 degrees away from 90 degrees. So if we get 90 minus 35, we will get 55 degrees. But remember that three-figure bearings or true bearings have to be written with the numbers. So we're going to write 0, 55 degrees.